Okay, hello again. We are on version 3 of graphing rational functions. That's the last assignment on this. We'll have 2 days to finish this one. I'm going to give you just 3 examples today. 2 of them you already know about. The third one is going to be new, and then that should wrap it up for graphing rational functions. All right, so this is one of the old ones. I wrote number 3 as y equals -3 over x plus 2. I put that negative sign in front of the fraction up with the 3 just to make it a little bit cleaner. So remember, we're looking for vertical asymptotes, horizontal asymptotes, x-intercept, y-intercept, and I think they want the domain on these as well. Let's start with the vertical asymptotes. The vertical asymptote, remember, is the value of x which causes the denominator to be 0. So in this case, x cannot be -2. So we're going to have a vertical asymptote at -2. So I'll put that in the graph. So again, that's x equals -2. Okay, horizontal asymptote, remember the degree of the bottom of the fraction is greater than the degree of the top, so we're going to have the x-axis as a horizontal asymptote. That equation is y is equal to 0 for the x-axis. Okay, so we want to find x and y-intercepts. Let's start with the x-intercepts. The x-intercept, remember, is where y is 0. If you look at the fraction, y will be 0 where when the top of the fraction is 0. The top of the fraction will never be 0, so there is no x-intercept. See if we got any y-intercepts. Y-intercept is where x is 0. Put in 0 for x in the equation, you're going to get -3 over 2 for y. So that's going to give us a point at 0, -1.5. And so there's your graph. That branch of the graph, I should say. It's not done. Okay, so we've checked out all the intercepts, and we still have a branch of the graph missing, so we're going to have to make that table to find the point on the graph to the left of the vertical asymptote. So for that, I'm going to choose -3 for x. That'll give you, if you look at the fraction, -3 over -1, which is +3. So -3, +3 is a point on the graph. That locates that other branch, so you can sketch that in there, just like we've done before. So that you got the 2 asymptotes, you've got the intercepts, although there was only one, and you got the branches of the graph, and then they want the domain. The domain is what can x be? If you look at the graph, x can be anything you want except for -2. So we just say the domain is x is not equal to -2. All right, there's number 3. Another one that's a review is number 8. And then the last one we'll do will be new to you. So number 8, I'm going to write like this. Y is equal to x plus 1 over x. Okay, let's look for the vertical asymptotes first. The vertical asymptote is what value of x makes the denominator 0. So the denominator cannot be 0. X cannot be 0 there. So your vertical asymptote is going to be where x is 0, which is the y-axis. So this is a vertical asymptote. The y-axis is a vertical asymptote. Graph is not going to touch there. Horizontal asymptote, by the way, that's x equals 0 there for that equation. Horizontal asymptote, notice the degree of the top is 1, the degree of the bottom is 1. So the horizontal asymptote is y equals the ratio of the lead coefficients. So y equals 1 divided by 1, which is 1. So y equals 1 is a horizontal asymptote. Okay, we got both asymptotes in there. Let's talk about intercepts. Let's go for the x-intercept next. The x-intercept is a point where the y-coordinate would be 0. So the value of x, which makes the top 0, is -1. Because remember, y is going to be 0 where the top of the fraction is 0. So -1, 0, we have an x-intercept. And so now we know where that branch is. Okay, so y-intercept is a point on the graph where x is 0. But if you look at that equation, x cannot be 0 because then you would divide by 0. So there is no y-intercept. So again, we have that problem where we just have one branch of the graph, and so we need to choose a point for x on the right side of the vertical asymptote and make a table. So I'm going to choose 1 for x. Look back up to your equation. That's going to be 2 over 1, which is 2. So 1 comma 2 is a point on the graph. And now we know what the other branch looks like from that 1 point. Okay, we got the intercepts, we got the asymptotes. They want the domain of the function. That's what can x be. And so you can look at that equation and say that x can be anything you want except for 0. So the domain is x is not equal to 0. Okay, last but certainly not least is the weirdest rational function that we will have graphed this year. So watch this one carefully. There's only one other on this version 3 that is similar. You can probably recognize it when you come to it. So that's number 1. So I'm going to write that as y is equal to x squared minus x minus 6 divided by x squared minus x minus 2. So the secret to working this one out and finding all the information you need is to factor the top and the bottom. So I'm going to write this as y equals I'm just going to factor that trinomial by guess and check. So that's x minus 3 times x plus 2. And the bottom factors also by guess and check. It's x minus 2 and x plus 1. Let's find the vertical asymptotes like we always do. The vertical asymptotes are the values of x which make the denominator 0. So look, there's 2 of them down there now. At x equals 2, your graph is not going to touch there because x cannot be 2 because that would cause that first factor in the denominator to be 0, which would make the entire denominator 0. There's another value of x which would cause that denominator to be 0, which is -1. When x is -1, that second factor is 0, which would cause the entire denominator to be 0, which you cannot divide by 0. So this graph has 2 vertical asymptotes. X equals 2 and x equals -1. Now, remember the rule for finding a horizontal asymptote. So if you look up at the original equation, the 2 degrees are equal. They're both x squared. And so the horizontal asymptote is going to be the ratio of the lead coefficients. Both lead coefficients are 1. So the ratio of the 2 ones is 1. So your horizontal asymptote is just going to be y is equal to 1. Okay, so this graph is going to have three branches. It's going to have a branch to the left of the first asymptote, a branch in the middle of the two vertical asymptotes, and a branch to the right of that rightmost vertical asymptote. So we can still find intercepts though. So let's find first x-intercepts. X-intercept is where the value of y is 0. Well, y will be 0 when the top of the fraction is 0. Well, that's going to happen twice. That's going to happen at 3, because if you put 3 into x in the top, one of those factors is going to be 0, which makes the entire top 0, which makes y 0. So 3, 0 is an x-intercept, but there's another one. If you put a negative 2 in for x into the equation, that second factor of the top becomes 0, which makes the entire top 0, which makes y 0. So those are 2 points on the x-axis where the graph will cross. So at 3, 0, that's a crossing point. So that tells us this branch. And negative 2, 0. It's right here, and that tells us this other branch. Okay, let's do, so we got 2 out of the 3 branches already. That's it, that's 2 of them. We just need that branch in the middle of the 2 vertical asymptotes. Let's see what we can do with a y-intercept. Y-intercept, remember, is where x is 0. Easiest way to plug in 0 into this equation is to use the original. If you look at the original equation before you factored, all the terms on top cancel except for negative 6, where they don't cancel, they go to 0. And all the bottom terms in the bottom of the fraction go to 0 that have x in them. So you're left with a negative 6 on top and a negative 2 on bottom. And when you divide them, you get 3. So that's a quick calculation for the y-intercept, which is 0, negative 3. Oh, sorry, 0, positive 3. Okay, now this is really weird. How do you finish that branch in the middle? Well, you could make some more points. You could plug in some more points to the left and to the right of it. That point that we know, that's still in between the 2 vertical asymptotes. But think of it like this: it's definitely trapped in between those 2 vertical asymptotes in the middle. It's not going to go down in any way because there's no more x-intercepts. So the only way this thing could look, and just as a rough sketch, which is really what we're doing here, is to kind of look like this. It's got to be trapped. It can't cross either vertical asymptote, and it can't open down because then you would have some more x-intercepts, which we don't have. So it basically looks like that. So that's the weirdest graph you've ever done in your life. 3 branches, but we found where they are. Okay, so we have our x-intercepts. This y-intercept I didn't label here, but that's we already did that. That's 0, 3. So we have all of our intercepts. We have all of our asymptotes. We have the 3 branches. I think they still want the domain. Remember, the domain is what can x be. It's easier to say what x cannot be. So it looks like x can be anything that you want in this equation except where you got a vertical asymptote. So x cannot be negative 1. X cannot be positive 2. Okay, that does it. So you got a couple days to work on this one. So enjoy. And then after these 2 days, we'll move on to another topic. So thank you for your attention and good luck.